Hello students, how are you? Hope you are fine and enjoying our online classes instead of sitting at a rigid desk in the classroom. Welcome back to my class. Today I am here to take class for standard 9. I will explain an interesting topic from chapter 5, that is elasticity. Elasticity. When we talk about elasticity, then picture something like this at first comes into our mind. We think in practical concept that the object which is stressed mode or compressed mode has more elasticity, but in reality this is not like so. So elasticity is not equal to flexibility. So what is elasticity? At first we have to know that elasticity means the ability of an object or material to resume its normal shape after being stressed or compressed. That means when we remove the applied force, the object will return back to its original shape. When we apply force on a spring, then the spring gets compressed and also stressed. So by the force, when a string gets compressed or stressed, is known as deforming force, and the situation which is occurring here is known as deformation. But soon they return to their original form when the applied force is taken out. Let's know what is deformation. Deformation is a change in shape due to an applied force. There are two types of deformation: elastic deformation and plastic deformation. In elastic deformation, this type of deformation is reversible. Once the forces are no longer applied, the object returns to its original shape. And in plastic deformation, this type of deformation is not reversible. All objects shows both elastic and plastic deformation. Within an elastic limit, an object will show elastic deformation. But if the limit crosses, then the object will show plastic deformation. That means the object will not return to its original position. Looks, objects deformed due to application of force. Here I have taken some position of rubber. By the application of force, the rubber get deformed like this way. Look, here I spin in a static condition in this position. When it is compressed from both sides, it will be like this, and when it will be stressed, the spring will be looking like this. So here the spring gets deformed by the deforming energy force. Types of deformation. So elastic deformation, that means the object returns back to its original shape, and in plastic deformation, the object is completely changed from its original shape. Now there will be a war between a bar of rubber and a bar of steel, and you have to tell which one is more elastic. Look, I think you will tell that the rubber is more elastic. It will stressed or compressed more than that of the steel, but this is not like so. When you apply force on the rubber bar or on the steel bar, then the steel will resist the deforming force quicker than the rubber, strongly. So we can tell the steel is more elastic than that of the rubber. That means elasticity is a property which means the object which object will resist the deforming force more quicker than the other object. That object will be more elastic. Look here. Here, if the elastic limit crosses, then the rubber will be torn off, but the steel will not. After by applying the same amount of force for the rubber and for the steel, the rubber will be torn off. So if your sample of rubber is less elastic than the steel, it simply means that at the same level of large stress, the rubber enters the plastic limit while the steel remains within its elastic limit. Look here, that means here in the elastic limit, when the rubber is stressed in the elastic limit, it will show elastic behavior. That means the more the applied force, the more the more deformation will be occurring there. But after the elastic limit, if the rubber is stressed more, then it will be torn off. Now I will explain Hooke's law. Robert Hooke, a famous physicist in 1663, invented this theory. So according to his name, it is named as Hooke's law. For understanding Hooke's law, we have to understand stress and strain, and we will try to understand that in the next slide. So what does Hooke's law state? According to this law, within elastic limits, stress is directly proportional to strain. Look, stress is proportional to strain. And you know, if we want to omit proportional sign and bring equal sign, then we have to bring a constant as a product with strain. So this constant, which is used here, relating stress to strain for each material, the name of this constant is modulus of elasticity. Look, here I have taken one string whose original length is L0, and after hanging a weight W, the length of the string is increased. That means the string gets elongated and its final length becomes L. So here we can see that for the applying force, that means for the deforming force, there is deformation occurring here in the string. That's why its length is changed. So now we will understand what is stress and strain. What is strain? So the relative change in length or shape which is made by applying a force from outside is called strain. We have seen when we applied the force on the string, then the length of the string is changed. So the relative change in length or shape which is made by applying a force from outside is called a strain. Therefore, if force is applied on an object of length L0 and the changed length becomes L, then its strain is L minus L0 by L0. That means the strain is the ratio between the changed in dimension to the original dimension. Here, changed in dimension, that means changed in length, is L minus L0 and original length is L0. So the ratio between changed in length to the original length is called strain. Now let's understand what is stress. You have to understand stress very carefully and you will try to make your concept clear. The force per unit area that develops within a substance due to deformation is called stress. If a force is applied on a body of cross-sectional area A and as a result deformation occurs, then if this deformation develops a resistive force F, then stress is F over A. That means stress is created due to resistive force. Because when we remove the force, the object gets back to its original position. So you see, it is similar to pressure, and its unit is Pascal, or simply you can write in short form PA. The unit of F is Newton, and the unit of area, that is cross-sectional area, is square meter. So its unit can be written as Newton per square meter, or you can write it as Pascal. So now elaborately we'll explain it again. Look, the length of the string was L0, and after hanging a weight, its length become L. So when we hang the weight W, then its length is elongated. That means deformation occurs here. The wire becomes deformed. So when the applied force will be removed, then then the string will return to its original shape. That means its length will be again L0. So this elongated length creates a counter force T in the wire. Here T is used to mean tension. That means generally when a wire is pulled, then the force acting in it is named as tension. Therefore, stress is T by A, because I have earlier told you stress is created due to the resistive force. Look, when the string is stressed by hanging a weight on it, that means by applying a force, the string is stressed, and so here force is applied and a displacement is occurring. That means work is done, and that work will be stored as a form of potential energy in the string. So for that potential energy, there will be created a counter force for which, and that counter force will be acting per unit area of this per unit cross-sectional area of this string, and that is known as stress. So therefore, stress is T by A, and we know from Hooke's law, stress is proportional to strain. So here stress is T by A, and which is proportional to strain, that is L minus L naught by L naught. So for omitting proportionality sign, we will bring a constant. Here the constant which is used, that is y, and this y is named as Young's modulus. Strain has no unit because it is the ratio of the similar quantity changed in length, whose unit is also meter, and original length, whose unit also meter. So that means strain has no unit. As strain has no unit, so the unit of Young's modulus will be the unit of stress, that is Newton per square meter or Pascal. Look, graphically, here I have shown you stress versus strain graph. Strain is placed in x-axis and stress is placed in y-axis, and the graph will be a straight line. That means the more the stress, the more the strain within in an elastic limit. But if the elastic limit is crossed, then the wire will get torn off. Here is a chart which shows Young's modulus of different material, and the Young's modulus here calculated in gigapascal, in the unit of gigapascal. Here you look, the Young's modulus is highest in case of steel, mild steel, and it is the least in case of rubber. So what does it mean? The more the value of Young's modulus, more force is required to deform it. Hence, a material with higher Young's modulus is more elastic than a material with lower Young's modulus. Now I will show you if pressure is applied in a confined air, then what will happen. Obviously, air is compressed. Look, here I have taken some gas in a container which is tightly, here a piston is tightly fitted at the mouth of the container, so no gas can come out, and the volume of the gas is V0. The initial volume of the gas is V0, and after applying pressure by the piston, the volume will be changed. The gas is compressed and the changed volume becomes V. So here, by the application of pressure P, its volume is reduced to V. So the strain here, here P is the stress, and strain is V minus V0 by V0. As I have already told you, strain means changed in dimension to the original dimension. Changed in dimension over original dimension. That means V minus V0 by V0. So, according to Hooke's law, we can write P is proportional to V minus V0 by V0. Here, the constant which is used is termed as P, and it is known as bulk modulus of elasticity. And unit of bulk modulus of elasticity is also Newton per square meter or Pascal. Dear students, I have given some formula and unit of this chapter because the chapter is almost finished. Some topics are left which I will explain in the next content. Look, P, that means pressure, equal to force applied perpendicularly on unit area. Rho, that means density, equal to mass per unit volume. P equal to H rho g. That means here P is the pressure at any point in the liquid is equal to H rho g, and it is proportional to H because rho and g are constant. Buoyant force B equal to V rho g. From Pascal's law, we learned this formula F2 by F1 equal to A2 by A1. From elasticity, we learned stress equal to Young's constant into strain equal to L minus L naught by L naught, and stress equal to F by A. Young's modulus Y equal to T by A divided by L minus L naught by L naught. Finally, T by A equal to Y into L minus L naught by L naught. I think these formulae and units will help you a lot while doing math. You must remember all the units, because if in the math, if you don't put the appropriate unit, your marks will be cut, and that is approximately 1 marks will be cut down from your copy. I want to finish my lecture. There is a homework for you. You will solve this math and send it to my messenger page. The time is today 8 p.m. So thank you everybody. There is a nice quotation from our Prophet Muhammad Sallallahu Alaihi Wasallam for you. A father gives his child nothing better than a good education. Goodbye everybody.